This is our first lesson on chemistry, Introduction to Chemistry. So there's our title. Moving on in 3, 2, 1. Our first heading is classification of matter, and you've seen a diagram like this. We're just going over the different ways we sort matter in chemistry. So we're going to start with a diagram with matter. And matter is grouped into two major groupings. We have on the left, we're going to have pure, and on the right, we're going to have impure. One of the ways that we define pure is constant. Composition. Constant composition means that no matter where you look in the thing, it's exactly the same, and you don't get a choice as to the proportion of things. It is fixed. Whereas impure, it's variable composition. So if the materials can come in different proportions, then it's variable and impure. If you have no say as to what the proportions of things are, then it's constant, proportional, pure. So on the left-hand side, pure can be again broken down into two different groups. On the left, we have elements. Elements is one type of atom, and compounds. Which is two or more types of atoms. In the impure, we also have two divisions. Depending on who taught you this last year, it's going to be solutions. Solutions are also known as homogeneous mixtures, and solutions mean one phase, meaning that when I look at it, no matter where I look, it all looks the same. Mechanical mixtures also known as heterogeneous solutions, and these are ones where it's multiple phases, meaning that when I look at a mechanical mixture, it looks different in different spots. So an example of an element would be gold. An example of a compound, e.g. table salt. An example of a solution would be Kool-Aid. And a mechanical mixture would be something like oil and vinegar dressing. So those are examples of the different types of matter. Moving on in 3, 2, 1. Back in grade 9, you looked at physical versus chemical properties and a little bit about physical and chemical changes. We're going to look at that in a little bit more detail. We're going to start first with physical. We're going to describe these things either as quantitative, meaning numbers. So in that word quantitative, you have the word quantity, that gives us a hint for numbers, versus quality in quantitative. And so quantitative have numbers and qualitative usually do not have numbers. Physical refers to a substance's internal properties, when they change state, what they look like, things like that. So the descriptors could be color, their physical state, an odor, a density, melting point, boiling point, and some of the others depend on what state of matter they are. For example, liquids, we'll talk about viscosity, or how thick they are. Are they runny like water? Are they thick like honey? Things like that. For solids, we'll often talk about texture. Are they rough or smooth? Are they malleable? Are they ductile? How are they hard or soft? Things like this. Gases, we normally talk, they're all pretty much similar. Chemical, however, refers to whether or not it changes from one substance into another. And so we talk about things like, is it flammable or not? Is it corrosive or not? Does it react with, or we say it does react with certain things or will not react with certain things. So those are some of the contrasts. Moving on in 3, 2, 1. Hopefully your grade 9 teacher talked about evidence of chemical change. Evidence of chemical change means if you see one of these occurring or detect one of these occurring, you've got a pretty good chance that you've got a chemical reaction. First, heat or light being produced or consumed. This is an energy change in the reaction, and if this is happening, there's a pretty good chance that it's a chemical change, unless it's obviously a change of state like melting, boiling, something like that. If a gas is produced and you're not trying to heat something up to boil it, it's probably a chemical reaction. If a solid is forming from solution, like if you mix two solutions together and get a solid suddenly forming, that's a chemical change. But if you're cooling something so it's just changing state, that's not a chemical change. A color change. It's pretty rare that physical changes cause color changes, but chemical changes usually will. Lastly, chemical change is difficult to reverse. Now that doesn't mean all physical changes are easy to reverse. If I take a tree and put it through a wood chipper, pretty tough to glue that tree back together into one piece and make it grow properly. So some physical changes are hard to reverse, but chemical changes are usually very hard to reverse. And that ends our introduction. Thanks for watching.